With our skeleton complete, we can start the process of creating and positioning our controllers. In this module, we'll talk about what controllers are, why we use them, and how they'll help us control our skeleton for animation. After that, we'll spend the rest of our time creating and positioning all the controllers so that we're ready to constrain them to our skeleton by the next module. When we start animating this character and moving these joints around, we don't actually want to touch these joints. As I mentioned before, they all have these inherent translation values that we shouldn't have to deal with while animating. That's why we create controllers to move the joints. And these are essentially objects in the scene that are attached to the joints, which control their movement instead. These controllers also have their own hierarchy relationship to each other so that we can move the skeleton in more intelligent ways. To give you a better understanding of how these controllers actually attach to the joints, I'm going to do a little demonstration here. So I'm going to go into the side view and quickly make a joint here in front of his face. So I'll just quickly place a joint there and hit enter. Now we have a joint chain. And if we look at this joint chain and we look at it in the channel box, we'll see that these joints have translation values like we talked about before. And if I move these around, these change. However, when you animate, you want to use these channels to tell objects in the scene where to be during certain keyed moments. So having all these different values in here doesn't help the process. So we're going to leave these joints just how they are. However, we're going to add a controller to this joint here to control its rotation and its translation. So up in the top left here, I'm going to go to the Curves and Surfaces tab, and I'm going to click on this first icon here, this circle curve. And that'll create what's called a NURBS curve, which isn't geometry or anything. It's more of a vector shape that we can use as our controller. What I want to do is bring this up to the joint. I'm going to rotate it so it's 90 degrees rotated. And then I'm going to hold V to snap it into that bone there. And this is going to be what we control the joint with, so we don't have to deal with the joint itself. You'll notice up here in the channel box that this NURBS curve also has its own transform values. But what we can do is freeze the transforms so we're dealing with a zeroed out number range. So let me go to Modify and Freeze Transformations. And now nothing changes with our curve, it still looks the same. However, all these values have been zeroed out and it's much easier to work with from now on. Now to attach this controller to the joint itself, we could do a physical parent like we've been doing before by selecting the joint and then selecting the controller and pressing P. That will have a very similar effect to what we want to achieve, where we can now rotate this controller and use just its transform values to animate the movement. But we don't always want our joints nested underneath our controllers. So what we need to do instead is create what's known as a constraint. So I'm going to undo this, and now both our objects are separated. And I'm going to go into the Riggings toolset and over to Constrain. And here you'll see a drop-down of all these different types of constraints that we can use. And we'll get to some more of these later on. But for now, we want to look at this parent constraint. So I'm going to go into the options box here. The effect of this constraint is very similar to the physical parent that you just saw. And that's why it's named a parent constraint, because it constrains the object to our controller with both translation and rotation. So we'll get the same effect using this constraint, but we won't have to parent the object physically. The last thing we should look at in this options box is this feature up here called Maintain Offset. We want to have this checked on, but let me show you what happens when we leave it off and we try to constrain these two objects. So I'm going to select the controller first, and then I'm going to select the joint and hit apply. And you'll see that the object we're constraining to the controller assumes the orientation of our controller here. And we don't want that. We don't want anything to move. So I'm going to undo that, and I'm going to instead click Maintain Offset and then hit apply. And now when we grab this controller, our joints turn purple here, so we know that there's a constraint on there. And I can move this around, I can translate it and rotate it any which way, and it follows just like it were parented. However, if you look in the outliner, our curve isn't the parent of the joint. Our joint simply has this constraint underneath it, telling it to follow along with this curve. If you ever constrain something in the wrong way, or you mess up somehow, know that that constraint that you've created through this tool here appears listed underneath the constrained object in the outliner. And to remove that parent constraint, I can click on it and just delete it. And now that constraint's gone and our controller moves without moving the joint. So for now, I'm going to close out this dialog box here, and I'm going to add one more layer to this so that we're prepared when we start putting controllers on our skeleton. I'm going to go back into the side view here, and I'm going to add one more joint onto this chain here. So I'm going to select the joint tool from the rigging tab. I'm going to click on that last joint, and I'm going to create another joint down the chain here. Now you can think of this chain here as sort of a spine and how we'll be controlling the spine. We'll want to rotate the base of the spine and have the rest of the joints follow. We also want to rotate each joint in the spine individually, so they'll each need their own controller. So for now, I'm just going to duplicate this guy and snap it to this joint. So potentially we can have these two controllers controlling our spine. Actually, now that I'm thinking about it, let's make this look a little more like a spine, because that is the spine of someone lying down. To make it a little easier to see, I'm just going to rotate it upwards. I'm going to take all the controllers and flatten them out. So essentially I'm just sitting this spine upright just so it's easier to read for you. And now that I've moved these controllers, I want to select them both, go to Modify and Freeze Transforms. So we're essentially back to where we were. Now we just have a more recognizable human spine. So from here I'm going to do exactly what we did before on both these joints. I'm going to constrain these controllers to the joint so we can rotate them. So I'll grab first the controller, and then I'll grab the joint. And I'll go to Constrain and click Parent. Then I'll go up to the next one, highlight the controller, select the joint, and I'm going to press G. And that will also parent because it was the last tool I used. And you'll see that these joints now have their own controllers on them, which is fine. However, because we now have a chain with controllers attached to each joint, when you go to rotate the former joints in the chain, so this parent joint with this controller, it doesn't work because its child is being controlled by its very own controller, and it won't move unless that controller moves. To fix that, we need to arrange a hierarchy relationship between these two controllers that replicate the hierarchy relationship between the joints. So this joint is the parent, and this joint is the child. This controller needs to be the parent of this controller. So I'll select first the child, and then I'll shift select the parent and press P to perform a physical parent. This way, if you look in the outline over here, we're starting to create our own hierarchy of controllers, just like we have a hierarchy of joints. Now, if we were to rotate the parent, the child also rotates with it, so we get both controllers moving at the same time. And if we wanted to, we can select both of these controllers at the same time and go to rotate them, and we get more of an arcing movement, which is more of what we'd want to see with a spine or something similar to that.